This lesson on relations and functions should go quickly, as most of these concepts should be review for you. Real quickly though, the relations and functions aren't exactly the same thing. A relation is really, exactly as its name implies, any relation that can be created between two variables is a relation. And so relations, if you ask the question, what does this have to do with this? You sort of created a connection, and that is a relation. Now, a relation can take on many forms. It can just be merely a small set of points. It could be some crazy looking relation like this. And so the relations can take on many forms. Here are some algebraic examples of relations. So you can have something that looks like this or something that looks like this, but there are two variables involved and we want to know how they are related to each other. That is a relation. Now, if we look at these examples here, we've got some relations. This one looks like a straight line. We've got this one here. We can even have a definition that relates x and y. We can say all the points in the first quadrant. That's relation. And we can have a scatter plot like this. And this is a relation. It's just showing a relationship between these two variables. Now that relationship might be very, very clear and definite, and others might be very ambiguous. But still, there is a relation, a connection between those two variables. Now, a function is a very special case of a relation. So, a function is when you have one input that creates one unique output. And so, typically the x is the independent variable, and for any value that I pick for x, I get a y, and that y is a unique value. As opposed to this. So here is an example of a function, and over here this is an example of a relation that is not a function, because if I chose a number like for x for 4, so I have x as 4, but I have two outputs for y. It can be positive or negative 2, because there are two options for my one input. Two things are coming out from my one input, then that is not a function. So one of my favorite cartoons that sort of typify this is Calvin and Hobbes, and here Calvin has invented a machine called the transmogrifier, and what he does is he can set the dial to anything that he chooses. He goes in as Calvin and he comes out as a baboon, for example. And so this box is like a function. One thing comes in, one thing comes out, and the machine changes you. So here one thing comes in for x, one number comes out for y, and we have a function. This would not be a function. Could this be a function? It could be. And how do we tell? There's something called the vertical line test. And what that means is if I can draw a vertical line all the way across the graph, and it never touches more than one point at a time, then that is a function. So clearly over here this is not a function. If I drew a vertical line, it would touch the graph at two different points. And over here the same deal. Over here it looks like if I were to draw a vertical line, it might, I don't know, it's hard to tell if any of these two dots are on the same vertical line. If not, then it's a function. So we're going to talk a little bit now about notation of functions. We have a couple of different ways that we notate functions, and one of them is the old-fashioned way where we have y's and x's, and then we have a new way, or where we use this notation here, the function, a function where x is the independent variable, so the f of x, and then we set that equal to some sort of function. This is a little bit more formal. You won't see this notation too often, but every once in a while you'll see it. And it just reads, we define a function f such that x is converted into 2x plus 3, right? And but this is how we normally see it. We usually see it like this. We have a function f, and what it does is it takes x and it converts it into 2x squared minus 3x. All right. So what does it mean if we find a specific value like 5? So if we take 5 and we substitute it into here, we change all the x's into 5 and we simplify. We can also put functions inside of functions. So for example, we could take x plus 2 and put it into this function f. So everywhere we see an x, we change it into an x plus 2 instead. So instead of 5 minus x, we have 5 minus the quantity x plus 2, and then minus x squared, so minus the quantity x plus 2 squared. All right? And then you can simplify. And so that's all that we're supposed to know for this particular lesson. Please try the problems.